Hello and welcome to the Inflation Drivers and Dynamics seminar hosted by CEBRA and the Center for Inflation Research at the Federal Reserve Bank of Cleveland. I'm one of the organizers of the webinar, along with Raphael Schunla at Brandeis University. And today I'll also be doing double duty as the moderator of the session. Today we have two speakers, Dmitry Taubinsky and Guido Ascari, who are going to present their papers on inflation research. The format of the seminar is that we'll have two presentations of approximately 15 to 20 minutes, followed by a question and answer session. If you have questions during the seminar, please post them in the Q&A at the bottom of your screen, and I will select questions at the end. And before we get started, a quick disclaimer that participation in this CEBRA seminar does not imply an endorsement by CEBRA or any of the member organizations. And without further ado, let me hand it off to Dmitry for the first presentation. Take it away, Dmitry.
Great. Okay. Thank you so much for inviting me to present my work. So this is joint work with Luigi Butera at Copenhagen Business School, my colleague Chen Lian at UC Berkeley, and my student Matteo Saccarola. The question we're after here is how do household level events or news about household level events influence people's forecasts of the economy? Sorry, 1 second. Oh, there we go. Okay. And the question is, well, are people Bayesian about it? It could be that the reason that household level events, in addition to macro variables, influence beliefs is just because of rational inattention. These are the things that people are exposed to. And, other kinds of information or shocks might not be observed by people. So it could be due to limited and rational, limited attention and so forth. It's also possible that people overreact to household level events, and it's also possible that some of this overreaction is due to emotional processing, where if bad things happen to people, people continue dwelling on the bad things, and they continue expecting more bad things to come. And so we're going to look at this question using a merge of household level survey inflation expectations merged with the Danish registry, where we can observe a lot of different kinds of household level events. So specifically, there are 3 parts to this paper. The first part is about people's forecasts of inflation. And we're going to show that forecasts covary very strongly negatively with largely idiosyncratic household income changes. And we develop formal tests of what rational expectations can possibly rationalize. And I'm talking including limited information and rational expectations. And we're going to show that this covariance is far too large in magnitude to be consistent with any kind of model of rational expectations. In part 2, we dig into what might be underlying these kinds of relationships between household level events and inflation forecasts. And we show that, one, memory seems to play a role because people's perceptions of past inflation covary even more strongly and negatively with largely idiosyncratic household income changes. And there's a very strong relationship between backcast errors, so errors in perceptions of past inflation and forecasts of, and errors in forecasts of future inflation. We also show that even unrelated negative events, so health shocks to yourself or your family, because these generate negative affect, it looks like those are also changing people's forecasts of the economy, leading to forecasts of higher future inflation and perceptions of higher past inflation. In part 3, we kind of synthesize this with a framework around how emotional events might influence people's perceptions of the economy. Okay, so the data, here we have a long-running monthly survey with about 1,500 participants per month and a very high response rate of 64%. So this is a survey that's run by Statistics Denmark. It's linkable to registry data via CPR numbers, and there are 3 questions in particular we're interested in. One is forecasts of inflation, so by what how many percentage points do you expect consumer prices to go up in the next 12 months? The second one is perceptions of past inflation, okay? And the last one is the categorical variable. This one is non-quantitative, which is, on a scale of 1 to 5, how do you expect your household financial position to change over the next 12 months? We can merge this with tax data, which gives us information about changes in people's income, potentially in a very granular way, where we can decompose it into labor income, non-labor income, and so forth. We have a rich set of demographics from people, and we can also merge it to the Danish National Patient Registry, where we're going to use ER visits as a last test of how completely non-financial unrelated events might influence people's perceptions of what's going on in the economy. The core, the empirical core of this paper is 2 sets of regressions, okay, where one regression involves regressing perceptions of inflation, okay? So that's the tilde FI. It's not actually, it's the reason we're using tilde FI here is it's not even a perception necessarily, it's a survey elicitation of people's perceptions of inflation. And we regress it on household level variables where XI can be recent changes in income. So the difference between last year and the year before that. It could be survey elicitations of people's perception of future income changes. That's the 1 to 5 survey question about what's going to happen to your household position. Or it could be realized future income changes. So that's the difference between next year and the current year. Okay. We can have all sorts of controls, including historical income and so forth. Now, when we run these regressions, the null hypothesis is that these 2 coefficients should be approximately equal. Now, why do I say approximately? If xi is a variable that's in your information set, so for example, it's a survey variable, then if you have rational expectations and it's in your information set, it should not be predictive of any kind of forecast error, which means that when you run these 2 regressions separately, the 2 coefficients of xi should be the same. Again, the 2 regressions is one is survey elicitations of inflation, the other one is actual realizations of inflation. Now, things like future income changes are not necessarily in the information set, but one of the technical results that we have in the paper is bounds on how much these coefficients can differ. And without getting into the details, since I have 15 minutes, they can differ by very little, it turns out, when this household level event is largely idiosyncratic. Okay, so they should be approximately equal in a manner that you can see in the paper, and in a manner that you'll see is going to be totally rejected by the kind of empirical patterns that we have. So here's a visualization of the first regression, and this is visualized with a variety of controls. The blue line here shows you how past income changes relate to people's forecasts of future inflation. As you can see, it's a very negative relationship. So approximately, 100% income growth corresponds to a change in about 0.7 percentage points decrease in perceptions of inflation. Okay, so that's the blue line. Okay, and again, this is these are income changes as measured in the tax data. So this is not survey responses. The orange line shows you that it's a very funny thing that these past income changes are so predictive of people's inflation forecasts because they are largely idiosyncratic to macroeconomic variables, which, it shouldn't be surprising. It's just one household's income changes, and they are, a lot of people, even in a smaller country like Denmark. Okay. Next, we can move to, this is kind of like your experienced past income change. What about when you get news about how your household financial position might change? Okay. And we can study this in 2 ways. One is to proxy for that with the survey question. Another one is to actually use actual realized future income changes. The reason we can do that, of course, is because we have a panel of people's finances that comes from the registry data. So if we are surveying a person in 2015, we also know what's happening to their income in 2016, 17, and so forth. Now, one question before we start running these tests is, do people actually have information about what's going to happen to them in the future? And the answer is yes. So people might be bad at forecasting inflation. They're very good at forecasting what's going to happen to their household income change. So this is this 1 to 5 categorical survey question. And you can see that people who say my household financial position is going to improve a lot, their income increases by 15%. People who say it'll worsen a lot, they basically, their household income does not change. And you can even look at CDFs of that, a CDF of income changes by the 5 possible survey responses. They're basically ordered by first order stochastic dominance. So people have a lot of information about what's going to happen to their household in the future. When you take the survey question now and you again look at how it relates to people's inflation forecasts, well, people's forecasts of what's going to happen to their household, this is the orange line, they're totally, again, unrelated to actual realizations of inflation. What about their forecasts of inflation? Very negatively related again. So people who are pessimistic about what's going to happen to their household, they expect consumer prices to change by another 1.5 percentage points, relative to people who are optimistic who aren't expecting much to change. Similarly, you can actually, forget the survey questions. Let's actually just regress. If people are informed of what's going to happen about them in the future, then just administratively, the future income changes that we can measure with administrative data are also proxies for people's beliefs about what's going to happen to them in the future. And so you can just directly regress on that, on future income changes. And again, and this is very significant, the relationship with people's forecasts of inflation is very negative, and statistically significant. It's about the same size, it's slightly smaller as the relationship with past recent income changes. Whereas again, the relationship with actual realizations of inflation, that's the orange line, totally idiosyncratic. Okay. And as I was saying, if you use the bounds that we calculate in the paper, the slopes between the blue line and the orange line in all 3 of our tests cannot be consistent with rational expectations. Okay, so what might be going on? Well, one, it seems like imperfect recall is implicated here. So when you look at the relationship, for example, between errors in people's perceptions of the past, so past inflation minus perceived inflation, and you relate that to their forecast of inflation, the 2 things are very, very strongly related. That's again inconsistent with rational expectations because we're predicting past perception errors with something in people's information set, and it's strongly predictive. So there seems to be a relationship in errors of perceptions of the past and errors in perceptions of the future, number 1. Number 2, this was really, really striking to us. You can run the same 3 sets of regressions that I just showed you with forecasts of inflation, except now put realized past inflation and perceptions of past inflation on the left-hand side. Okay, and again, there's 3 sets of tests that we have. One is about recent income changes, one is about forecasts of household financial position, and the other one is realizations of actual future income changes. So take the coefficients that you get from those regressions and compare them to the coefficients that we got when we ran it with forecasts of inflation instead of perceptions of past inflation. It turns out that perceptions of past inflation are even more sensitive to all 3 of these household income change measures, and how much larger are the coefficients there? Somewhere between 50% to 100%. So perceptions of the past are even more sensitive. So not only is memory imperfect, but it's actually what our perceptions of what happened in the past is even more strongly colored, not just about what happened to us in the past, but even what we expect for ourselves in the future. Quantitatively, this is pretty much impossible to rationalize, not just with rational expectations, but any model that we currently have of even overreaction, because all of these income change measures are largely idiosyncratic. Instead, what we think is going on is something that we don't have even in our kind of quasi-Bayesian models, which is affective association. And the simple hypothesis that we have here is just when bad things happen to you, you remember more bad things from the past, and those bad things from the past color your forecast of the future. And in particular, because it's all about emotion, it doesn't have to be even that it's bad things in the financial domain. lead you to forecast bad things about, economic variables. It could be other bad things. And here we are using emergency room visits. The reason we're using emergency room visits rather than any kind of other health shock or other kinds of shocks that you think might act on emotion is just because these are relatively frequent and very well measured. And so what we have is actually largely causal design where we're saying, take two people who have exactly the same number of emergency room visits. Okay, it's just that one happened to be surveyed about inflation right around the time when someone was going to the ER, and the other person was surveyed far away from that ER visit. So it's kind of a causal design of what happens to your forecast of the economy right around the time when you're visiting the emergency room visit. And the answer is it makes people's forecasts and perceptions of past inflation higher. And moreover, and consistent with what I've shown you before, the impact is, again, actually higher on perceptions of past inflation rather than forecasts of future inflation. And so to summarize, and we have some more survey evidence that kind of connects the dots a little bit on mechanisms, but I think the punchline is actually a very simple hypothesis that, now that I've written it down, I kind of see it in myself all the time. Maybe it's because I'm particularly moody, but I think we all actually are, which is when bad things happen, we think of more bad things. And when we think of more bad things, we forecast more bad things to come. So, I think that's what's going on. I think it's very relevant, actually, for how people forecast the economy. It's very relevant for what we even mean by consumer sentiment and the kinds of things that shape consumer sentiment. And I think there's a lot more room to investigate these kinds of ideas going forward, with a combination of survey evidence and administrative data being kind of one very useful approach, because you kind of get the best of both worlds. You get to observe a lot about what happens to people, and you can also really try to get more at mechanisms by combining it with surveys and experiments. So thank you very much.
Thank you, Dmitry. Guido, we'll hand it over to you now. And remember, if anybody has questions, you can put them in the question and answer box and we'll answer them at the end.
Okay, I think you should be able to see my slides.
Yep, it's great.
Okay, first of all, thanks to Dominic and Raphael for inviting me to join this webinar series. Thanks for Dmitry for the excellent presentation, very insightful report. So I try to keep the level. We'll try with this paper. This is a joint paper with Jacopo Grazzini, a colleague at the University of Pavia, and Domenico Massaro at the University of Milan. It's called Great Layoff, Retirement and Post-Pandemic Inflation, and usual disclaimer apply. So what we know is that inflation has been unexpectedly high in the aftermath of the COVID-19 pandemic, and that spurs a large debate that, of course, I have no time to summarize here about the causes of this. What we do in this paper, we investigate as a possible, extra effects through labor market tightness that comes from a particular channel, which we call the Great Retirement, following Montes et al. What do we mean? So we try to basically see if there is a contribution of this channel and try to quantify also the contribution of this channel in the aftermath of the COVID-19 pandemic inflation surge. Now, what we're talking about, so these are three graphs. So we're talking about this spike here. So between March and April 2020, roughly 22 million workers has been laid off. So that is called the Great Layoff because of the COVID. And then you can see here the reaction of the labor force. So obviously the labor force dropped. And here from the graph, you can see that it took quite a bit of time, actually quite a lot of time, a very persistent drop, if you want. So in order to make up, for the previous level, if you fit a trend here, we were almost there now, but for very persistent drop relative to trend, at least in the labor force. That might be caused by the permanent increase in actually the number of retirees. Retirees from 2 million from February to July 2000. And you can see here the trend. and there's a permanent increase here, then stay there, and the gap has not been resolved yet. So the idea here is that a temporary, very temporary, you can see here, spur in the layoff determined a very persistent contraction in the labor force that may have some effects on wages and therefore inflation. We can also show that the labor force participation rate change depending on the age, and in particular, you can see that, for example, for 1624 and 2554, the labor force participation came back quite swiftly, especially for the youngest. But the 55 plus, instead, the labor force participation dropped and actually continued dropped, right? So like a downward trend. So again, these are guys that are not going back to the labor force. And that's what is called the Great Retirement. So in this paper, we do two things. We're going to provide you with reduced form evidence of the following chain of events. The pandemic induced a great layoff that triggered a surge in early retirements, and that's what is called the Great Retirement, that reduced the labor supply, increased labor market tightness, and ultimately caused inflationary pressure through higher wages. And therefore, we find evidence that a transitory, as I said before, labor demand shocks due to COVID generated a very persistent labor supply endogenous response. Actually, not shock. So then we would like to quantify these effects on the inflation surge, how much of the inflation surge can be due to these effects. In order for doing that, we write down a mutation model with endogenous labor market participation and retirement. To account for these facts, we're going to structurally estimate the model and to quantify exactly the impact. And we find that the retirement has a positive impact on inflation, which is roughly 3.7 cumulative percentage point up to 2023 Q2. So this is roughly divided in 1 percentage point 2020, 1.3 2021, and 0.9 in 2022, which made up for roughly 1/4 of the overall price increases in the episodes, which is of 16.2% between 2020 Q1 and 2023 Q2. There's also a negative impact on output, simply because there are less people in the labor force, which is actually not very strong, quite negligible, and we try to understand why, which is about a 0.4% cumulative GDP growth less. Okay, so recent issues we skip. Empirical evidence, so let me go quickly on the empirical evidence. First, we do this, we run this regression. Regression is basically showing you that laid off workers are more likely to retire, and this is actually something that is known in the literature. And what we show here, there's nothing special about COVID in this respect. So here you can see we regress, the retirement. So on the effect if you were employed or laid off in the month before. Here is on the wall sample, and you can see that people that were laid off are more likely to retire. And this is particularly true if you are old, so over 55, rather than on the full sample. You can see from the coefficient here. Here in 2 and 3, we control for people that were laid off only 1 month before the survey was taken, and you still have the same effects. But the important thing here in column both 3 and 6 is that what we say, there's nothing special about COVID, because when you put control for COVID or for interaction effects, these are not significant. So that means that these effects are not particularly due to COVID. So it's not that people, because of COVID, decided to retire to enjoy life because they understood that there was a pandemic and therefore there's some things more important in life than working. But simply that's what has always been happening. So it's always been happening that if you're laid off, especially if you're old, so over 55, you're more likely to retire. And the fact about COVID is that COVID was simply very large. And that's why you can see it in the statistics very evidently here, in the statistic I showed you. Okay, so that's what I just said. So what we are going to do now, we're going to try to convince you of these effects and try to study the impact of this great layoff on retirement and wages. we're going to do a shift share regression or a Bartik instrument. So we compare counties which are more exposed to contact-intensive industry to counties with less exposure to contact-intensive industry. And this because we are going to exploit the specificity of COVID, which is exactly hitting some sectors more than others, particularly hospitality, for example. So this is the shift share instruments. So we're going to build these instruments in which this ELN19 is the employment share of industry in industry N in county L in 2019, so before COVID. And here is the change in employment at the national level in that particular industry. So then we have 302 sectors and 280 counties, and we run, the usual kind of regression in which we look compute the quarterly cumulative changes in the outcome of interest that will be in the next slide. So it will be retirement wages in particular on this Bartik instrument or shift share instruments, and we have a bunch of control that I don't have time to go through. This is the main results. So we multiply by minus one. So this means that counties, so let's look at the effect on retirement. Counties that were more exposed to the COVID shocks because they have a higher share before COVID of sectors more exposed to COVID, they see a relatively higher increase in retirement, as you can see here. And this takes a while, right? And it's kind of persistent. And you can see that there is no pre-trend. What is the effects on the nominal wages? Again, there's no pretend, and you can see that slowly nominal wages are picking up, meaning that in these countries in which there's been a relatively more retirement because they've been more exposed to layoff due to COVID, the nominal wages are going up. Interesting relative to countries in which they were less exposed to COVID. Interestingly here, we are looking also at the effects of other people not in the labor force. And these actually decreased. That means that, as the old guys retired, the youngest guys kind of try to make up slowly over time for this missing labor force. And that is induced by the fact exactly the wages are going to increase, and therefore some people that were out of the labor force before are going to choose instead to participate to the labor force and get in the market. And this is consistent roughly with the story here that you have the young people that are going back in the labor force, so this is the labor force participation, to make up for the fact that instead the people that are over 55 permanently retired. So the story we're telling you about is that there is a very temporary demand shock due to COVID, a great layoff, and you can see here job openings that actually increased after the initial decrease, translated in an endogenous shortness of supply of labor that actually shifted to the left because the labor force participation decreased because of retirement. Now, unfortunately, given the data that we are having, so we're looking at, so the data on county and industry, here we don't have data on prices, so we cannot actually run a similar regression for inflation. So in order to try to quantify, the magnitude of these effects on the recent inflation surge, so how much this early great retirement contributed to the recent inflation surge, we're going to write down a model and estimate a model. So the model needs to be a model with certain characteristics, in particular a model with endogenous labor market participation. So we're going to build on a paper by Campolmi and Gnocchi in the JME. And we extend their framework to having two agents. So there will be a tank model, but the two agents we are young and old agents. And they have heterogeneous productivities, especially on home production, and therefore different outside option. It will be a model with self-friction, and I'll say something about more there. The only difference between, let's go to the two type of households. As I said, there is young and old, indexed by A. That's the utility function that they have, okay? And household members can be either employed and they earn a salary, unemployed, and they can therefore allocate time between job search and home production, and they receive unemployment benefits, or they can be non-participants, in which case they dedicate all the time they have to on production, and they receive only if they hold a pension. Okay, so that's the only difference between the old and the young in our age, in our model, is that if you are an old agent and you decided not to participate in the labor market, you receive a pension. You don't if you are young. They have own production, which is this utility of labor, and you can see here that they can have different productivity in the own production. And this gamma is the amount of time that they, if unemployed, they devote to job search. So this is the amount of time devoted to own production, which is 1, the total amount of time you have, minus if you are employed, or minus the time that you devote to job search. For the sake of time, let me go very quickly on the model. There's an exogenous separation rate, there's a pool of non-employed, there's a split between job searcher and non-participant, which is a job finding rate, there are search friction, amortis et pitarides, standard matching function, the wage is determined by standard Nash bargaining, and then we have both intermediate goods and final goods producer, and intermediate goods producer differentiated final goods, while the intermediate goods produce an homogeneous goods, and then the final good is differentiated by this final good producer, that therefore they have couple pricing as usual. So there is also a standard Taylor rule that in which monetary policy, the nominal interest rate respond to inflation and the output. So what we're going to do, we're going to estimate this model. Some of the parameters calibrated, some are estimated. We're going to use as observables the real GDP growth, inflation, policy rate, the change in labor force participation, change in retirement, change in real wage, and change in real consumption. And then we have the smoother shocks, and we're going to, given the smoother shocks, run a counterfactual. So we simulate the model economy as if the great retirement never happened. So how do we do that? We basically play around with the productivity and total production of the old agents. Okay, so if you can play around, so you decrease the productivity or total production of old agents such that they decide not to retire. So just to give you an example, so that's the baseline model. So these are the data. Okay, and this is the counterfactual, right, in which we have the pre-trend and we keep the level of retirement as at the pre-trend level. So we have the filtered shock, and on top of that, we add this shock to the production of the old agents at home in order for the old agents deciding not to retire. What you have here, consistent with the data that I show you, is that the real wage in the counterfactual would have been less because people would have not retired, and therefore you don't have these effects of decreasing the wage. I just have 1 minute to go, if that is okay. And then you have inflation would have been lower, right? So that's the difference. So that's the effects we are looking for, right? So the effect to quantify, and also some effect on GDP. Now, looking at this graph, it seems that the effects are minimal, but when you accumulate them over time, here you have the cumulative contribution of excess retirement to inflation, so the sum of these differences, and this is the cumulative contribution on GDP growth. On GDP growth, the effect is negligible, exactly because of the increase in the wage, the people that were before outside the labor force decided to come back to make up for their retirement, as I said, especially the youngest one, and therefore the effect on growth is negligible, while the effect on inflation is not so negligible. It's about, as I said, 3.7 percentage point. So you have a positive income on inflation, which is roughly 3.7% annualized overall, and a negative impact on GDP growth, which is actually negligible. Well, I think I need to conclude now. So this is just to say that we also match the behavior, which this is not estimated, but the behavior of young individuals out of the labor force, which are the ones that actually make up for the great retirement, as I said. So to conclude, we find empirical support for the following chain of events. A massive pandemic-related great layoff caused the great retirement, and therefore a transitory labor demand shock generated a persistent labor supply response, actually not shock. And that generated inflationary pressure. So we measured this through the lens of a new Keynesian model with endogenous labor market participation in young and old agents, and we find that the positive income inflation is about 1/4 of the overall increase in prices for the great retirement. Effects can explain roughly 1/4 of the total increase inflation in the inflation surge post-pandemic period. And I think I should stop here.
Okay, thank you for two great presentations. So now we have about 10 minutes for question and answer. And I'm going to use the moderator's privilege to start with a question from me for Dmitry. And so do you know whether the people's wrong beliefs about inflation, do these create any sort of aggregate bias? So it seems like, in papers about like that argue that households overweight like grocery inflation or something like that, that sort of creates an aggregate bias where everybody in the economy thinks inflation's too high. Is that what's happening here, or is this more like idiosyncratic, unbiased differences?
Yeah, I mean, the variation we have right now is idiosyncratic variation, of course. But if the mechanisms that we are trying to flesh out here are the right ones, it suggests that the non-idiosyncratic shocks might affect inflation expectations in pretty interesting ways that we have not fully considered. And this also kind of goes to one of the Q&A webinar questions as well, which is that, one thing this highlights is that, beyond the standard economic considerations of how supply or demand shocks might affect consumer prices, one thing this suggests is that there's a whole nother dimension to this. So just tying it back actually to the previous presentation, a shock like COVID, which does all sorts of other things to people's lives, mostly negative things, might actually be particularly bad in terms of how it changes people's inflation expectations. So that's one implication. I think another implication is also, when we're trying to predict behavior from inflation expectations, I think there's two channels to consider, right? One is literally like whatever expectations people have in their heads, those are going to affect their consumption and savings decisions. That's the channel we all understand and love. The second thing this brings up, however, is that, to the extent that inflation expectations are proxies for people's emotional states, which is what our paper suggests, and to the extent that emotional states affect all sorts of other decisions as well, people are in a bad mood, people are feeling down, people are feeling great, that probably has all sorts of influences on their consumption decisions as well that I think we don't have much research on, but I think it's an interesting hypothesis to consider. If that's true, there's kind of this whole other second channel to what we might, to what, inflation expectations or consumer sentiment indices more generally might be picking up and what they might be predicting. And then the last thing, again, to all these questions is, to the extent that inflation expectations are actually picking up all of these other kind of like emotional variations, some of which is coming from other variables like forecast of income, and so forth. I think it does suggest that, if we can really understand like the anatomy of what exactly impacts all these different forecasts, when we're forming a consumer sentiment index, how we weight all of the different variables that go into it, and how we consider other variables that we might put into it might actually change. So understanding the psychology of this could, I think, potentially help us, construct even more powerful indices of consumer sentiment, or indices of consumer sentiment that kind of have different implications for different domains, are differentially optimally predictive.
Okay, thank you. So for Guido, this is from Raphael, have you looked at an international dimension to this? Is this something that was happening in a lot of countries?
No, we haven't, partly because of so good data for county industry we couldn't find for many countries, apart the US. While there's the other question by Rafael, I think, also about uncertainty. I think that's a good one. We should put a band. That's your, if I understand correctly, we can put a band on this cumulative, inflation. Is that what you want?
Yeah. So just because everybody can't see that question, so Raphael's
Sorry.
other question was, did you gauge the uncertainty, the uncertainty of the cumulative effect? It might be able to see. It might be nice to see the evolution of uncertainty over time as well.
To put a band on these numbers.
Yeah. And then, so I had a question for you about whether you could calculate labor productivity growth in your model, right? So one of the other striking features post-pandemic has been, this big growth in especially in productivity in general, but especially labor productivity. And I wonder if your model would actually show people substituting to capital. And
surely we have some. So suppose you measure labor productivity just simply Y over L. I think what you have a counterpart in the data. I think, let me see. Of course, we can look at that in the data and in the model. Yeah, we don't use it at the moment, but surely we can do that. We can look at the implication of labor productivity in our model and compare that with the data, a bit like what we do.
Yeah, I mean, it's probably too much to ask that your paper could.
Yeah, I mean, the model
could both explain the
exactly. We don't do much
a third of inflation and also labor productivity growth, but
we also don't do much with the shocks because the model is actually. I mean, it's not a medium scale. It's kind of a relatively small model, so we don't want to go too much into explaining a lot of other stuff because probably we need some other ingredients in the model.
Okay. And we promised to let you guys ask each other questions if you had one for each other. So
can go if Dmitry.
Yeah, go ahead.
Yeah, so wonderful and actually very surprising results and presentation. So I was thinking, this bad things snowballing effect, right? So when thinking about bad things, comes other bad things. So one thing actually you already mentioned. So because what are the aggregate implication of this, right? And so you can take the COVID period. The COVID is probably bad for everybody, right? And then if you look, if you have some aggregate implication that can come from this, right? Because if I think about past inflation, the backcast, past inflation is easy to get. I mean, people should know, right? And that simply means that probably they don't care much about inflation. If they, if something happens to me, it's changed my perception of past inflation, which is easy to get to check. That means that probably they don't care much about it. So that another possibility was simply that inflation, is something. I think about my mother. My mother probably doesn't know what that is. It doesn't care about inflation taking any decisions. I think whatever the decision it is. Now we know that we have a large literature with randomized trial experiments that shows that actual inflation expectation do affect the consumption decision, investment decision by firms, blah blah blah. But yeah, it might be simply that these type of consumers instead simply don't care, and therefore they just have this strange bias with inflation because they don't look at inflation, they don't know what inflation is, and therefore they don't take inflation into account when they take any decision. The other question I have, did you try, or can you with your data build, this is maybe related to what Dominic said, build an idiosyncratic inflation basket for the type of the single guy? These guys are different inflation baskets, so the perception of inflation can come from the different inflation basket that they consume, and might be that actually that's what determines the change, the fact that you have a slope when you look at the idiosyncratic perception.
You mean because household level income changes relate to
Different inflation
the
paths.
prices that people?
Because what you show is that if you look at the inflation, the aggregate is flat, as you would expect, not because the idiosyncratic change in income, for example, are not. But they might affect, the idiosyncratic basket. Yeah, sure.
It could, yeah. I mean, I think we tried kind of more local measures of inflation. I mean, not as granular as you're talking about. That doesn't change. I think even that, but it would be hard to explain how news about future income changes then predict people's perceptions of past inflation.
Yeah, that's true.
Even if there was some kind of differences, I think that one is very hard.
That's very
to explain. Or similarly, ER visits probably are not really. I mean, I guess maybe if someone's really unhealthy, it slightly changes, your purchase patterns. But I think it's hard to explain all of the data with that. But I think more generally, I totally agree with you on your prior points. So one is I think we definitely need more evidence about the tie from these kinds of survey elicitations to behavior. It would be really, really useful. I've been basically like trying to get all of my students to work on this now. It would be really, really useful to have some kind of empirical design, either something clever in the field or even, if it's a controlled experiment to show kind of this link from kind of like emotion to stated beliefs to actual decisions. And to your other question, then, really, issue is like, well, are people really so sophisticated, and they're solving, consumption savings decisions, taking into account future prices and so forth. I don't think so, but I think what is true is that people do have a very keen awareness of like, are things becoming, or I don't know if it's a real, but they have some kind of subjective, strong assessment usually of, are things becoming more or less expensive? And I think it is also a very emotional thing for people. And again, I think that is maybe actually an even more powerful channel than the standard one we consider of people thinking about, well, what are like the income and substitution effects of consumption now versus in the future as future prices are changing. But, having surveyed people, from some of the other surveys, people have like very, very vivid and emotional associations with the price changes that happened in the past. Like your phone bill goes up, that's a very it's a very painful thing for some people, and so I think that is probably the channel through which all of these kinds of things are linked.
Well, thank you for that. I think as the moderator, it's my responsibility to say that we're over time now. And
Okay, sorry.
no, that's fine. This is great. And so thanks everybody for coming. We have another one of these next month. And Dmitry, we'll look forward to when your students have papers on this topic, and we can invite them to come here and present their papers in a year or two. So thank you.
Thank you very much.
Thank you
Okay,
both
thank you
so
so
much.
much. Bye.
Super interesting and so many questions. So thank you.
Bye.
Bye, everybody.
Bye.